Hello student, I am Amit Kumar Mondal, lecturer in physics at Kingston Educational Institute. Today I will talk about uniform and non-uniform circular motion. When I talk about circular motion, the particle is in circular path. So here it is our circular path. Particles are rotating in a circular path. Let the particle is at point P. To describe the motion, we have to calculate first the unit vector. For that, we have to give the direction or Cartesian coordinate system. So it is our x-axis and this is our y-axis. To calculate the unit vector, there are two types of unit vector. One is along the radially outward direction, that is along the PA direction, and another is tangential direction, that is along the PB direction. So there are two types of unit vector. One is along PA, another is along PB. So along PA the unit vector is E of R. Along the PB the unit vector is E of T. So one is unit vector radially outward, and it is our radius, circle of radius R, radially outward, that is along PA vector. It is called this is called E of R. Another is unit vector tangential direction, that is along PB vector. Along PB vector, this is called E of T, unit vector hat. So how to calculate ER and ET? So let's suppose this PA vector makes an angle theta with the x-axis and PB vector makes also the angle same theta along the y-axis. So here are the two components of the PA vector. PA vector has two components. What is PA cos theta along x-axis, so it is I hat, plus PA sin theta along y-axis, so it is j hat. So what is the unit vector along PA? It is ER equal to PA vector by magnitude of PA, that is cos theta I hat plus sin theta j hat. So we calculate ER vector. How to calculate ET vector? So then in the similar way we have to resolve the PB vector. So PB vector can be written as the component of PB along the x-axis is, here it is PB. So PB sin theta is along the minus x-axis So minus PB sin theta is along the x-axis. So minus PB sin theta along the x-axis, it is I hat plus PB cos theta along the y-axis, so it is j hat. So ET vector tangential direction is PB vector by PB equal to minus of sin theta I hat plus cos theta j hat. Okay, so we calculate ER hat unit vector and ET vector along the tangent. Okay, so we can write here ER vector is cos theta I hat plus sin theta j hat, and ET vector is minus sin theta I hat plus cos theta j hat. Okay, now what is the position vector at point P when the particle is at point P? So the position vector of the particle at point P, it is nothing but R vector. Okay, so R vector is OP vector. OP vector is nothing but the magnitude of OP and the direction along the radius. So OP is here our radius and ER is cos theta I hat plus sin theta j hat. So thus I calculate the position vector R. If I calculate the position vector, then I can calculate the velocity at point P. So velocity at point P, how much? V equal to dr dt, derivative of R. So here R is the radius, so R is constant throughout the circular motion. So R is constant, so the derivative of R is 0. Okay, so R is constant, so if I derivative dr dt, so only the derivative function is sin theta cos theta derivative, so it is minus sin theta d theta by dt I hat plus cos theta d theta by dt into j hat. We know d theta by dt is our angular velocity omega. So V is here R minus sin theta omega I plus cos theta omega j. So if I common omega, V equal to R omega minus sin theta I hat plus cos theta j hat. Okay, so if I write down here V vector equal to R omega minus sin theta I hat plus cos theta j hat. or r omega et. Okay, so the magnitude of vector v, velocity, is r omega because it is the unit vector. So v equal to r omega. If I know the velocity vector, we can calculate the acceleration at point P. So acceleration at point P is a vector dv dt. As r is constant, so what is the derivative here? R is constant, so here d omega dt minus sin theta I hat plus cos theta j hat plus omega minus cos theta d theta. Now this derivative, the derivative inside the bracket, cos theta dt I hat minus sin theta d theta by dt into j hat. Okay, if I write down second term, if I write down the second term in the first way, so here d theta by dt, here d theta by dt is omega. If this omega comes out and here it is r, so minus r omega square cos theta I hat plus sin theta j hat. Okay, and here if r goes inside, that means if r d omega dt equal to ddt of r omega, and r omega is here v, so it is dv dt. So r d omega dt is dv dt into minus sin theta I hat plus cos theta j hat. In that way we can write a equals to r omega square e of r plus dv dt e of t. Thus we calculate the acceleration at the point P in a circular motion. Okay, so I clean this and write in a fresh way that the acceleration here a in general minus r omega square e of r dv dt e of t. E of r is a unit vector radially outward direction, it is the tangential unit vector. Okay, if this is true, then we can distinguish what is uniform circular motion and what is non-uniform circular motion. First, I talk about uniform circular motion. So uniform circular motion. For a uniform circular motion, speed is constant. In a circular motion, the speed of a particle is constant or uniform motion. So in uniform circular motion, speed of the particle is uniform or constant. So if this is true, then here is the main equation. A equal to this term. In the main equation, dvdt equal to 0 because speed is constant. So here dvdt equal to 0. This implies to a vector equal to minus r omega square er vector. We can write down this in that way: r omega square minus er vector, and the minus er vector is radially inward direction. So here in that direction it is our A vector for a uniform circular motion. So if I delete all of these, now it is not necessary too much. Okay, so A vector is now radially inward because it is minus of ER. Okay, so A vector is now radially inward. So the magnitude of the A vector, is r omega square, or r omega equal to v by r. So r v square by r square equal to v square by r. This type of acceleration is called centripetal acceleration. Okay, this is called centripetal acceleration, and this type of acceleration is only observed, or only this type of acceleration is observed in the uniform circular motion. So if there is a uniform circular motion, or the speed of the particle is constant in a circular motion, then there only act centripetal acceleration on the particle. Okay, and this acceleration is radially inward direction. Okay, so only centripetal acceleration is act on a particle for the uniform circular motion. So what about non-uniform circular motion? So now talk about non-uniform circular motion. If I talk about non-uniform circular motion, the speed of the particle is not constant here. So speed of the particle is not constant here. So there exists dvdt term. So there are two types of component. So the overall acceleration is here minus r omega square e of r plus dvdt e of t. In another sense we can write here r omega square is v square by r, okay, minus er plus dv by dt et. If this term is I called AR component and this term is I called AT component, acceleration along the radius, acceleration along the tangent. So here it is our AR acceleration, here it is our AT acceleration. So acceleration is in that direction, acceleration is in that direction. So there are two types of acceleration here. So the resultant acceleration is in between them, vectorically sum. So the resultant acceleration is the vector sum of AR component and AT component, and it makes an angle alpha along the R, along the radial component. Okay, so if this is true, we can calculate the magnitude of the acceleration A. We can calculate the magnitude. So what is the magnitude here? The resultant acceleration, the magnitude is root over AR square plus AT square. So it is AR square is v square by r whole square plus AT square means dv by dt whole square. It is the magnitude of the resultant acceleration. And what is the direction alpha? Alpha is here tan alpha. Tan alpha is the component, normal component AT divided by AR. AT is dv by dt here and AR is v square by r here. So this is the whole description of a non-uniform circular motion when the particles is not in a constant speed and the resultant acceleration is not in a radial direction nor in a tangential direction. It is the resultant of the radial component and the tangential component, and the makes an angle theta alpha with the radial component. And this is the overall acceleration in a non-uniform circular motion is the angle or direction of the resultant acceleration. That's all for today. I hope you all enjoyed this video. Thank you.